Okay, today we're going to be figuring out how to do the noble gas configurations as well as figuring out how to do them without that little fill-in chart that I gave you last week. So what you need to do first is copy this stuff down. So stop the recording and copy this entire screen. Now, if you do not have this page, you can get it by going to my website, and you can do that by just going to, first of all, the home page, and then standard stuff, class forms and charts, and then you go down here where it says letter C, orbitals and principal energy levels. That's what PEL stands for, and I believe this is the guy right here that you want. And there it is. Ooh, not that one. Nope, we're gonna. Okay, the one you actually wanted was the second one down, and this one has not only the sublevels, but it also tells you where those sublevels are located. So this block right here is the P block, and it goes all the way from here on down to here, and it's 6 wide. This is the D block, which is 10 wide, and this is the S block, which is 2 wide. So the F block is 14, and those are your numbers that you just copied down off of the page that I just showed you. Now, if you have not already done so, on this chart you want to be sure to circle the different blocks, the P, the D, the S, and the F. And if you need to, stop your recording now. All right, back with us. Now we're going to look at how to use this, and I'll put an arrow up so we can actually point, and then everything will make a whole lot more sense. Now, our first job is to figure out how to find a noble gas to go along with any element, and I'm going to take our example that I have that I'll show you in just a minute. If we're trying to find the noble gas for chlorine, so if we want chlorine, all we have to do is go up one row and over to the end of that row, and that will give us the noble gas to start our electron configuration as well as our orbital filling. Okay, the orbital notation is what I called it on the chart. So if we were to do indium, what is the noble gas going to be, class? Krypton, right. One up and over to the end, and that gives us krypton. If we wanted to do xenon, what would the noble gas be? Who would it be? Krypton, right. So we start with krypton, and then we put in 5s2. That means the 5s sublevel has 2 electrons. Then we do the 4d 10 because the 4d has to be full before we get over here to xenon. So that's sublevel 4d on principal energy level 5, and it will have a total of how many electrons? 10. Okay, and because we're doing xenon, we will have 1, 2, 3, 4, 5, 6 electrons, right? In the 5p. And because we have 6 electrons, we have actually 3 orbitals that they will fit into, 2 per orbital. This is just the overall. Now, this is where it gets a little dicey. When we're talking about an element down in the F block, because you're not familiar with the periodic chart super well yet, what we need to realize is that this whole thing is sandwiched in right at this dark black line. So if we were doing no, just HO, what is that? What's the name of that element? Holmium, yeah, homey little guy. Anyway, holmium. Holmium, if we were going to do holmium, how do we figure out the noble gas now? What do we do? Okay, we're going to go all the way to the left. We're going to follow our nose, so to speak, because everything follows in order. And now we have to follow this little double-headed arrow. And that leads us up to what row? Row 6. Okay, so now we know that we have to go, we're on row 6. We go up 1, end of the line, and we know that our noble gas will be xenon. How many learned that for the first time today? Come on, let me see your hands. Come on, be brave. Everybody else knew that? I don't believe it. Okay, anyway, so 5F. By the way, for those of you watching, we only had 2 or 3 people raise their hands. Anyway, 5F. Let's take Lawrencium, LR. Okay, so how do we find his noble gas? All the way over to the left, and that leads us up to actinium. Up 1, all the way to the right. Radon is the dude. Okay, so that's the guy we want to use for our noble gas. I did this as an example to show the students how to go about doing what I'm asking you to do. Your homework for last week included, it included the noble gas electron configuration only. And what we're doing today is after we get the noble gas electron configuration, we're going to go to the orbital diagram. So this is how it works. We find our noble gas. So for chlorine, let's go back to the page that we were just looking at. So we go back here and we look at chlorine, go up 1 over to the end, and yes, it is neon. So we're going to take and put in neon. That's our first thing. And those of you in the class, write this down. This is a good example. And you can use this as an example of exactly the way you're going to do your homework. So when you do your homework, the first thing you write on each line is the element and its atomic number. Then we put in the noble gas in brackets, not parentheses. The parentheses are different. Remember, chemistry, they're so doggone picky. Yeah, they're just really picky. Okay, so if we are in chlorine, if we're doing chlorine, what row are we on in the periodic chart? Okay, chlorine is right here. Yes, it is row 3. That means it's in principal energy level 3. So we start with neon, and then we just follow our nose. We go to the next element. Okay, the next element is sodium. Now the first thing we're going to write is 3s, and this 3s will be full. So how many electrons will it have? All right, so let's go back here and let's look at how that looks. Principal energy level is the 3. It's also the sublevel number. So this is principal energy level 3, or line 3 on the periodic chart. And then we're talking about it's being an S sublevel and an S orbital. There's only one of them. So one orbital can only handle 2 electrons. That's why this is 2. And so we have, whoops, went the wrong way. Here we go. So we have now filled these guys up. We've got the 3s full, and now we literally follow our nose, left to right, top to bottom. So now we go across the 3p until we hit what? What are we looking for? Chlorine. So how many electrons do I need to get to chlorine? 5. That's why the 5s, or the 3p, which is the block that we were just in, is going to have a total of 5. Now, is this making more sense to a lot of you, I hope? Okay, now let's go over to the orbital diagram. We're going to take that from the same place. We've got to have the 17, which is the number of the element, the atomic number, and then the noble gas is going to be the same, still going to be neon. Now, except now this time, what are we going to do? The 3s is going to be there, and what are we going to put after that? Remember, this is the orbital diagram, a la the fill-in chart that we used last week. How many underlines in the S? You're saying 2. I think you mean 2 electrons. No, no, no. This is the S. Okay. No, this is the S. 1 orbital. Because it can only hold 2 electrons. That's the max, right? It's so easy. Believe me, when I started teaching, I had a nightmare with this thing. And when you try to say the 3s4 and the 4s5, and you start, all those numbers just mash in your mind, and you're going nuts by the end of the day. I had to do that 5 periods a day until I got it pretty good. At any rate, so this guy only holds 2, and don't feel badly if you get them wrong. I understand your pain. Totally. Okay, and now we're going to have 3p again, only this time, instead of the exponent like we had back here, we're going to put underlines, right? So, how many underlines do we have in all p sublevels? 3, and that represents 3 orbitals. Okay? Now what you do is you go back over here, and that tells you the arrows. All right? There's my arrows. Okay, so I've used up 2 electrons, but I don't really need to worry about it because over here I've got the number of electrons that I'm going to have in these orbitals. So, how do I put my arrows in? No. Up. 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 Because every orbital has to have 1 in a given sublevel. And this guy right here is my sublevel. It's a 3p sublevel. But all p sublevels, 1, 2, no, we don't have it in row 1, but 2, 3, 4, 5, 6, and 7, they all have 3 orbitals. Okay? Now I've used up 3 of my 5, so then I do what? Go back and put my down arrows, and I need 2 of them, and I'm done. Okay? Is that making some sense? This is exactly how I want you to do the do now. So let's do the do now, and we'll check that in just a minute. Now what we're going to do is check out the do now, because that's one good example, and we'll show you what that looks like on a student's paper. And so what we're going to do is let the class see what I'm doing, and we should be now over to this guy. Okay, cool. We're up. All right. Now, looking at this, we have argon as the noble gas because bromine is on the row below it. But bromine should be, bromine is. Okay. And then over here, we've got the 4s with 2 because bromine is on row 4. Okay, that 2 represents 2 electrons. The 3d, you'll notice that number is 1 below the row number. Okay, so that sublevel is actually in 3, but we write it here. Okay, and then we have 5 electrons across in the P, takes you to chlorine, which is why that 4p has 5 electrons. Then when we go to the orbital, what do I call that thing? Anyway, the orbital diagram, the bromine is there again, the argon is there again, and now we have 2 electrons, and we get that from here. Okay, we got 2 electrons in the 4s, please don't move. And then we have 3 electrons, or I'm sorry, 10 electrons in the 3d, which comes from that number, and we have 5 electrons in the 4p. Okay, for the homework tonight, October 26th, a Monday. We are doing for rows 4 through 6, columns 2, 13, 14, and 15, a total of 12 problems. On column 2, our row 4 is going to be this. Okay, calcium is our element. He's number 20. If you go up 1 from calcium to the end of the line, you will get argon. Up 1 row on the periodic chart, that is. Okay, so argon is our starting point, and we continue from there. So in column 2, argon integrates with beryllium. Yeah. Column 2, row 4. Oops, 4. 1, 2, 3, 4. Calcium. So calcium's our first guy. That's why I put number 20 there. And then we go strontium and barium. So those are the elements that we're going to do noble gas configurations for and orbital diagrams. I would appreciate it if you'd lay your homework out exactly the way you see it here. So the electron configuration will be on the left and the electron configuration on the right. Or I'm sorry, the orbital diagram on the right. I went down to this guy, tellurium, because he's in column 13 on the 6th row, and if you look at him on the periodic chart, let's go back to the periodic chart. Tellurium is right here, and as we go back and we find xenon, we have to start with the 6s, and then we do lanthanum. That's in the 5D sublevel. And lanthanum, we have to, after that, we have to go right down here to the 4F. That's how the guys in the F block work. They're actually sandwiched in. And if you look on a periodic chart with numbers, you'll see that lanthanum is number 57, and cerium, which is in the top row of the 4F. Okay, this guy's cerium. Okay. The periodic chart number, the atomic number, is 57 for lanthanum and 58 for cerium. And that's how you know that the cerium here knits right in here. So the next thing we do when we fill up this whole row is we're going to go back up here and continue across. So we literally do 6s, come down and do the 4f, all of which are full because we're going here. Everything to the left fills first, including the guys down here, because now what row do we know these guys are on? Huh? What row are they on? 6. Yeah, 6. This part of the F block, this top row on the F block, is actually in row 6 of the periodic chart. They took it out so that everybody in this column and 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 this column would have similar properties. And the properties are caused by their what's called valence electrons. All of these guys have 8 valence electrons, except for helium, which has 2. And that's the electrons in its highest principal energy level, the s and the p electrons. Okay? That's going to mean more as we go along. Anyway, let's go down to the radon. If we were doing row 7, we would go to actinium, and then we have to go down to the F block 5. F block in 5. It would actually be 2 levels up from the row that it says here. Okay? So again, we would go across here, then we come back, and we go across here until we get to the P's, which don't even show on this particular chart. But this row, as I believe, I think it is now full. This is an older chart. And then we have, I think, the guy under tellurium and the guy under bismuth after that. At any rate, that's how you do your homework. You should be successful tonight. See you tomorrow.